Just got your pictures out of there in time. Okay, so just proceeding on and moving on, and I'm gonna lament, which is my favorite word of the year, which means just really talk about the things that bother me, kind of thing, and really need this in this chapter. That we got four conic sections, and that, as a matter of fact, just to give you a warning. We're going to do circles today, and then tomorrow is your day. Today's going to be a lengthy set of notes because I like talking about the things that you need to be worried about. So tomorrow we'll clean it up, circles and parabolas. And then Monday and Tuesday we're going to do ellipses. And really what you need to do is get some file folders going. I always think of the brain like a computer. As a matter of fact, Samuel's family had a little rough week this week with some of the kids and just being kind of down, about certain things happening at school. And you ever notice when you get in a bad mood and something bothers you, and then all of a sudden you start thinking about all the other things that bother you? You ever notice that? Your brain is full of chemicals. So when you start thinking negatively, those chemicals are going. Then I think it activates your brain to think about other things that happened when your brain was in that process. Does anyone know what I'm talking about there? Makes sense? So I think of the brain as a computer. That's sometimes the best time to just shut yourself down for a second. Taking a nap, or if you had a bad day, just get to bed, read a book, do something different, pass out, fall asleep. Next day, your computer's restarted, and you go from there. So I always like thinking about the brain like a computer in that respect, and tell my kids about that all the time. And hey, if you have a bad day, guess what? You might have a bad day tomorrow, but a good day's coming in the future. Just hold off and wait until that happens, and things will be good. But another thing, wow, you got a fly here, don't you? Oh, if someone gets that, if someone steals that fly and presents it to me, I'll give you a major award. Isn't that great? We got a little contest now going on. All right, neat. Major award for killing the fly. All right, I can't turn on the music though, so we'll just have to grab it. But anyway, another reason your brain's like a computer are what we're doing right now. You can't get out of your seat though and start diving and trying to kill the fly. People are getting excited about killing the fly now. All right. So you have to have folders, file folders, right? Don't you have file folders in your Google Drive? And you got to get a file folder for parabola and lock it, because the parabola is probably the most unique of all of the conic sections that we're going to have. There are similarities. So as we go through circles today, and then when we go to ellipses and circles, those file folders can be pretty close to each other because they have a lot of similarities. But then ellipses become a little bit different, so there's minor differences. And then hyperbolas have similarities to ellipses, but something major happens a little different. So those can be kind of close together too. And then all three of those have a lot of similarities about how the equations look. Parabolas, keep it separate, man. Keep those on, in a different area. Because parabolas are the only ones that have x squared on one side equals y on the other, or switch. Y squared equals x, and they have two different sides going on. Circles, ellipses, and hyperbolas, the equations are very similar looking. Here's the one thing at the end of me doing the circles thing here, that they'll have every four of these will have in common. But let me finish this off here. Now I'm going to give you my stupid little story I gave the others as you have this written down. Now that you have the circle in there, put a coordinate plane by it. And I decided to keep the circle in quadrant 1 just to make it simple. Gotcha. And as soon as that hand came up, I knew something was amiss. I had the screen frozen in class. So understand this. All of what we're doing is graphing these objects in a coordinate plane. So I inserted a coordinate plane in there. So this is the circle in a coordinate plane. By the way, input. See, this is what dictates all graphs. The equation I'm going to write when I'm done with this derivation makes input. Say it one more time. Are you saying output, you girl? Okay. All right. Sabina, did you write all the things that she's got to? Okay. You got to get all those sentences down. Okay. So here we go. Excuse me, that just snuck up on me. All right, I'm going to bore you with another story. If anyone wants to borrow this book, just tell me. I have a book, I think it's at home. I don't know if I can find it. It's probably in a box down in the basement called The History of Pi. Ooh, doesn't that sound like a page turner? All right. And I swear to gosh, I did actually start reading the first two chapters and then I stopped. But I do remember in that book, the mysticism of a circle to the ancients. We'll call them the ancients. And I used to have these posters, the math in other countries or whatever, like the world of math, and I have India, China, I don't know. There was I had like 8 different civilizations, and the things that they contributed to the math that we know today. And many of those, and actually this is true, those civilizations at ancient times didn't know the other civilizations even existed. And this is what fascinates me. They didn't even know the other civilizations even existed. Some are on different continents where we weren't even sailing on the seas yet. And yet all of these civilizations had some sort of concept of pi. Doesn't that fascinate you? And it should. Just like civilizations that didn't even know each other existed, for some reason built pyramids. Why would we as species not knowing each other, why would we have pyramids on all of our continents? Why would that be a thing that humans that don't even know others exist have the same structure in their head? It's kind of interesting stuff there. So that's one thing I learned about the history of pi. All these different civilizations had some incarnation of trying to derive this number. And of course, when I talk about circles, you should think of the number pi. And then in that book, and I'm doing this now because imagine this is a ground. Imagine this is outside. This is what the ancients did because they didn't have paper readily available and pencils. They didn't have that stuff. They had rocks and stone, and they have to chisel, back in those ancient times. So they'd stick a stake in the ground, and then they put a string around that stake, but with a loop on it so it wouldn't wrap around the stake. And then they pull that string out, and then it would tether, and then they then walk around the ground and mark the ground and go all the way around, and therefore make a circle in the ground. They'd measure the string, and they'd measure their walking around the circle. And actually, the string, they would think of it going all the way across. So what's 2 radii called, everyone? What's 2 radii? Diameter. They physically measure what the diameter is, twice the radius, and they physically measure what they walked around from one point and then getting back to that point. And you know what they would do with those 2 measures? Divide. They would take circumference divided by the diameter, and no matter what size their circle was, they kept coming up with the same number. And it fascinated them and it baffled them. How is this possible? How can this be a thing? And that's why the circle became this mystical object, this figure. I'm going to give you one more thing. This is kind of like, this chapter is like a geometry kind of subject. Do you even know what the word geometry is derived from? Geo. No one can answer this last year. You know what geo stands for? It's in geology. Geo. What do you think geo is? What's your first incarnation? Earth. You know what metry is? Geometry, metry. It's a word that starts with an M. Measure. Geometry was this thing about measuring Earth, understanding the world around us. Actually, Pythagoras, I had my Pythagoras, and did you notice my shirt yesterday? Pythagoras fighting with Einstein for c squared. A squared plus b squared equals c squared, e equals mc squared. Pythagoras and any other mathematician in ancient times were actually theologians as well. And actually, Pythagoras was musical. I know that from Donald Duncan, Math Magic Land. Did anyone ever see that movie, Donald Duncan, Math Magic Land? That makes me sad. It's actually kind of a cool little cartoonish, it is a cartoon. But because music, anyone in music? Music is mathematical, right? It's very mathematical, how the sounds are made and all that other stuff. So geometry, measure of the world, they were theologian type people. They were people that wanted to understand the world around them and what was going on. Actually, very cool stuff. Learned that in many different books. Blah 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 blah. So imagine that stake in the ground, and then imagine that we start walking around and create this circle. So I'm going to stop. I'm going to randomly stop right there. I could have stopped anywhere. There's an infinite amount of points on that circle. And guess what we're going to call that circle or that point? Since it's in a coordinate plane, we're going to call that point x comma y. Now, here's what all 4 file folders have in common. But in this case, it's a center, not a vertex. The center, the most important point of a circle, we will call h comma k. That's for commonality. That's so we can, in our 4 file folders, understand h comma k is the most important point for all of our objects. An ellipse has a center. Guess what? H comma k. A hyperbola has a center. Guess what? H comma k. Okay, and then what is this called? What is that called for the circle right there? The radius. But you know what I'm simply going to call it right now? It's the distance between these 2 points. And then we're going to convert that to the word radius. And the distance between the center and that point is what makes the circle. It's the rope. It's the rope from the ancients that they used in order to draw the circle in the ground. Okay, now, what is distance formula? This is Monday's lesson. And yes, you're expected to have this memorized. When you take the SAT and ACT, you're going to need to know this formula. I guess I'll turn this here and make sure I talk more at the mic. The mic I bought does not work the way it's supposed to. It's supposed to be an omnidirectional mic, but every time I turn my head, I notice the sound gets really bad. So I should get a different one. You ever hear of that omnidirectional mic? Instead of having to talk right into it, it's supposed to catch all sound and hear you guys as well. But here's the distance formula. Again, SAT, ACT, you're going to have this memorized and known. And because of the way this works, I do have a choice. I could do this minus this or this minus this. We're going to go the x, y minus the h and the k. So it's the x is subtracted, but go in this order. And then the y is subtracted, go in this order. Then I'm going to do 2 things. One is, that's distance. You know what? I want to keep writing that because what's another circle word that starts with a D that's important that I said already? I don't want you to think that means diameter. That's just distance of these 2 points. But now I'm going to change that to what was said. That distance is called a radius. So now I'm going to call it R. That's the definition of what is important in a circle. Same thing. And I'm going to do one more thing. I should have done 2 things at once, but that's okay. Oh, no, I got it. And then I'm going to square both sides. And then reveal the equation of a circle down there. And then you can go ahead and write it. By the way, input, say it. That's what an equation is. And I'm going to prove this when I graph my first circle. That when I find another arbitrary point on the circle, I'm going to input, output, and prove that that circle, that point, is a solution to the equation because it makes the equation true. And I've done that ever since we've started teaching any kind of graphing. And I think that's been very beneficial. I haven't done that every year. But an epiphany came to me that I think these students don't really know what graphing is. They just want to have these rules and how I get a picture and I can sketch it. Or just use the graphing calculator and copy the picture. That's tragic to me. When you don't understand this input-output, it actually clarifies a whole bunch of things in mathematics. I think it is working out for many of my CAT students, as much as I complain about them. Complaining about the 10, 15% when I give a test and they get 10% on it. I can't imagine that happening. You have to be doing something quite goofy in here during lessons for that to be happening. There's just no excuse for it. And that's the biggest thing that's baffling me right now and throughout all my classes. I get 10 A's and then I get a 15%. Something is happening. Okay, so that's the point, and that's why we went x minus h. So now, oh, there we go. There's our file folders. I told you separate all 4 file folders, but every dang file folder, h comma k, is the most important point. And the same rule applies. We're thinking opposite. X minus h, so it says x minus 2. 2 is the x coordinates of the center. If it says x plus 4, it's negative 4 is the x coordinate of the center. Now again, center is important in a circle. Parabola, vertex is important. Also notice in parabola, they're separated on opposite sides, the x and the y. These are together on one side. And that's going to be a commonality with ellipses and hyperbolas. You'd be amazed how close ellipses and hyperbolas are to the circle equation. There's just minor differences. Okay, I'm not going to, all these say sketch. I'm going to shut it down after a couple for sketching. I think we can sketch just fine. Mickey Mouse questions. Like I say, tomorrow is your day. I'll have circles and parabolas. I think I might have, you're always supposed to bring your laptop. I think I might have a Bellwork laptop thing I'm going to set up and have you at least answer like some basic questions about circles and ellipses. Oh gosh, I got all the words in my brain. Sorry, my file folders are all getting intertwined. I got to separate them again. All right, parabolas and circles. Okay, so I'm stalling. And this is all the examples. We're going to write an equation of a circle in standard form for each, or we're just going to graph. We're going to do a whole bunch of stuff. The directions might change for each one. And then notice my sketch, my coordinate plane there. It's like that for on purpose. Okay, so here's the whole thing. It's x minus 3. I'm not going to be cryptic about it. I'm not going to ask anyone. It's opposite. Or think about this. It is, what happens when I plug in 3? 3 minus 3 is what? 3, 2, 1, go. 0. It's that, so make sure that happens. That is a very key component. And then plus y plus 2 squared. The radius is 4, but what goes here in the equation? 4 squared. So that's 16. All right, and then that's the equation. But the radius is 4, so that's another common mistake that people make on this. What do I put there? All right, and then I'm going to go, my microphone that I just complained about is in my way here. 3 right and 2 down. And it's very simple how you graph a circle then. Now, again, the tether, the rope, it's going to be 4 all the way around. But we can't go 4 diagonally, and then what's this point? 1, 2, I can't, there's no notches there. So to graph a circle, it should be quite obvious. I'm going to go 4 up, 4 down, because I can't directly go 4 up, spaces up and down, and right and left. I'm going to get 4 points. All right, because that's what a radius is. It's that common distance. Again, it's 4 because it says it's 4. But notice the difference in the equation. The equation has 4 squared. The radius is still 4, though. So that's the length of the rope. I do like bringing up that book. If you could visualize a bunch of ancients with a rope that's 4 units long, and then they walk around and sketch in the ground. 4 units all the way around. All right? All right, 3, then one more, 4 to the left, and 4 to the right. I got to get that notched in. I like my spacing. And then you do this. And I made a mistake, and I'm glad I said this. Like when I was talking about the center, because in a parabola, the vertex does solve the equation. You know why? The vertex is on the parabola, right? Is the center on the circle, yes or no? No, so the center is not going to solve the equation. The center makes this side 0. 0 doesn't equal 16. The center makes the circle with the rope, but it is not on the circle. So I almost made a mistake. I tried to insert the center last hour, and I'm like, wait a minute. Oh, right. And I screwed up because I just thought about that concept. So there's a big difference there, and I think that's excellent thoughts, And then I'm just going to arbitrarily pick one of these points. I like picking that negative. Negative 1, negative 2 apparently is on this circle. Left 1, down 2. So I might ask a student, what's f of -1? First of all, what's the answer? We should be able to answer that right now. 3, 2, 1, go. -2. Input, say it. That's an input-output question. But let's prove it. What's -1 minus 3? 3, 2, 1, go. -4, and I'm going to yell again. Here comes angry Mr. Samuel. Sorry, new girl. I know it's like kind of a shock only 3 days in. This insane person up in the front here. But I swear to dog, Olivia, if you take -4 squared and get -16, I might sit you outside in the rain today. I mean, just get out. Just go sit out there. Because what's -4 times -4, everyone? 16. Why are people writing -16 on their paper? This makes me want to throw a desk up against the wall. All right? This should never be happening. You know, but then in the quadratic formula, did we have, do you want me to sing?
Yeah.
The opposite, did you say that?
Can you sing for me?
Okay, here we go. Did you ever hear the quadratic formula? The opposite of b plus or minus, come on, the square root of, let's stop here, b squared. You know how many people for b squared put a negative in that position? That makes me so sad. And it's got to stop. Why am I acting like a jerk right now? Stop doing it. Stop. These are the things that are causing people their major destruction here. This is positive 16. All right, anyway. Ooh, I got to breathe more when I'm teaching. Anyway, -1 minus 3 is -4. -4 squared is 16. And then what happens when I plug in -2 plus 2? What do I get, everybody? 3, 2, 1, go. 0 squared. 16 plus 0 equals 16 true. That means it is a solution for this equation. That's why it's a point. Input, say it one more time. Output. All of those points that I found there. All right, so I do like asking those questions. I ask those of my CAT students all the time. F-up questions after they're done graphing. And it is working out. I know I complain, but I'm talking about the 10, 15% of my CAT students that just get destroyed on tests because they're doing goofy stuff. Either not doing their homework, I assign them the compass and they refuse to come, or they come with a bad attitude because they don't care. You know, you're here, you're in school. You know, use your time wisely. Someone tried to reach out to help you. Do something about it. Okay? All right, so we should know, and then this is a common mistake here. What's x minus 0? It's just x. And I forgot to write that. My bad, dogs. Roof. Let's go up here. This is a common thing. Go back to the standard form when I just taught you this. X minus 0 is x. Y minus 0 is just y. So we should take a note to self because students screw this up all the time. This is an equation of a circle where the center is not 1, 1, it's 0, 0. I get that all the time. Students try to tell me that the center is 1, 1 for that circle. They think they feel 1x squared. There's a 1 in front of the x squared. All right, so a good note to self, go back up to the standard form. Really probably highlight that because, again, this is even people that really do their work and really do their stuff. They mess this up all the time. All right. So I just thought about that when we see this example. This is just x squared, and then this is y minus 8. You know what? I'm going to graph this because this circle is so cute. It's like one of the cutest things I've ever seen. And I swear to dog, you guys, I get my CAT students and I ask, hey, what's 1/4 squared? And then they want to run out of the, oh my God, he asked me a fraction in squared. I can't do fractions. What's 1 squared, everybody? 3, 2, 1. What's 4 squared, everybody? 3, 2, 1. Why is that hard? Every time CAT students see a fraction, they all want to run out of the room. Please don't call on me. Why? I don't understand what happened. I don't get it. Why fractions seem to be so difficult. Watch how cute this circle is. Oh, you're going to cry. It's so cute. All right, here we go. And then you know why I'm doing this? Because I have to go up 8. 1, 2, 3, 4, 5. Right? Okay, I got 6, 7, 8. I do tend to make mistakes sometimes. So I went up 8, and then there's the center, and I got to really zoom in on this, and the stupid program only allows me to go so far. And the radius is 1/4. What? Here's a half. I'm in the way for the screen. So a fourth is like this. Oh my gosh. The circle's so cute. I want to squeeze its cheeks. Look at that little thing. Aw. Then let's zoom back out. That little circle just trying to get by in the world. Look at it. All right. Anyway, let's move on. Okay. You know, it's going to tell you how to solve this one. Input, say it. Okay. So what did I do in 2 examples ago? I found the graph of the circle, and then I inputted one of those xy's to prove that it's a point. I'm not going to graph this. What we should know is this is the standard form of an equation. And this is the center. And then what's this other point? We're going to say it one more time annoyingly. Input, say it. This other point should be able to be plugged into this position because it should solve the equation. Oh, but I don't know what r is. Well, guess what? The only thing that's left is r squared. So now I'm going to be able to find what r is if that truly is a solution point. That's all you do. It's so simple. It really is big. Did I do something wrong? 3 minus negative? I bet you I wrote it and it didn't. Oh, I guess I did forget to write minus and negative. Sometimes I write it and the pen makes it disappear because my pen stinks and it drives me nuts and it's my enemy. This is negative 4 squared. What's negative 4 squared? 3, 2, 1, go. If you write, say, negative 16, get out. 3 minus negative 5 is 8. 8 squared is 64. Now, here's a thing. Here's a true, and I said I wasn't going to graph this. What do I need to write the equation? Okay, and then I think students don't understand this. The equation is not this right here, inserting, our new r squared value. You must bring x back. I have students that don't get this, so that's why I have to cover it, and I'm not going to judge you. This is a common error. People write, what's the equation of the circle then? They write negative 6 plus 2 squared. Wrong. You need to bring the x back to consider all those infinite x comma y coordinates that make the circle. There's an infinite amount of points, so I need that x position back. This is a very, very common error. And then bring back the y plus 5. There, did you see that? That disappeared. So sometimes that does happen. But now here's the question. What goes here? Is it 80? Or do I have to take the square root of 80? 3, 2, 1, go. I bet you it's a 50-50. I heard some people say square root and some just said 80. What is that position, everybody? Let's go back up to the form that we're looking for. What does that say? R squared. So what is it, 80 or the square root of 80? It's 80. And that's what goes there. And that's the equation. If I wanted to find R, then what I would do is take the square root of 80 and then get that decimal. By the way, what's the square root of 81? 9. So the square root of 80 would be like probably 8.9-ish. And then what you would do is go to the center and go 8.9 up, down, right, left. I'm worried about this question. Oh, good. Gotcha. You're right. That is another mistake by Mr. Samuelis, or I wrote it and the pen made it disappear. Because sometimes I keep writing and I don't know. Do you ever notice that? I write and then it just disappears after I write it? This pen is my nemesis. Okay, what did we already talk about with the diameter? We should speed this up now, although we're doing all right here. What's the diameter? 2 what's, everybody? And I guess I'll do a better job than the other class. Let's just do a quick coordinate plane, 3, 8. And then 6, 2-ish. All right, this is what the circle might look like. It's going to be tough doing that. That's really bad. Sorry. Let's make it more like right over here. And then that's the diameter. What is on the diameter? Starts with a C. I have no time for this. The center. And where is that center in that diameter? In the, anyone? Middle. So guess what? From Monday, you need the midpoint formula. The center is the average of the x's, the average of the y's. ACT, SAT, you have to have that formula memorized. Then remember I told you, distance formula has minuses. People sometimes put minus in the midpoint formula. If you put minus 3 minus 6 is -3. -3/2 is over here for x. Could that possibly be the x coordinate of the center? Yes or no? Common sense, no. So sometimes at least think about the picture and think about the answer that you got. All right, and that's error analysis kind of thing. Problem is this is 9/2, which is 4.5. Okay, so here's 4.5. That's a reasonable x coordinate if I thought about at least the picture of this and thought about where that diameter is. And then 10/2 is 5. All right, this is approximately 5. If this is 8 high up here, maybe not. My sketch is really bad if we had a coordinate plane. At least it's reasonable and in the ballpark. So I think I did the right formula. All right, being more than just a robot and plugging in numbers and not thinking. And then the next thing, okay, now I have this, and now this is exactly like the last question, but I have choices. I now have h comma k. I have 2 different x, y's, and I'll just choose one of those. Choose you. 3, I'll choose minus 9/2, and I'm not going to the calculator because there is a value to knowing how fractions work. And then y has to be 8 minus 5 squared, and that's what I'm trying to achieve. What is r squared? If I had Lexi Samuelis here, she'd instantly make 3 6/2. She's my 6th grader. 6 minus 9 is -3/2. Ooh, if I called on a student, what's -3 squared? 3, 2, 1, go. 9. Did someone say -9? Get out. What's 2 squared? 3, 2, 1, go. 4. So this is -3/2. -3/2. Square that, you get 9/4. And then 8 minus 5 is 3 squared, which is 9. So what would Lexi Samuelis do next? What's 9? Blank over 4. What's the blank? 9 equals blank over 4. 3, 2, 1, go. 36. Hear everyone around you. You that cannot figure that out, you are severely and totally behind fractionally. 6th grade. It's actually 5th or 4th grade that Lexi Samuelis did that stuff. I get mean about that because my cat students are horrendous at fractions, and it really upsets me. How that is a thing, why that is so, why we can't think fractionally at all. If you think, well, I'm not going to college, I'm going to go into buildings and trades, and I'm going to be you're going to be ridiculed on the worker set, wherever where you're working at, if you don't know how to deal with a fraction. That is exactly what a tape measure is made out of, fractions, right? Everyone that deal with a tape measure, it's all fractions. So you need to know fractions in the real world. I had to do a lot of stuff in my house, and if I didn't know fractions, I would have done it all wrong. Let's just say that. So being mathematical actually helps me naturally be able to do stuff in my house. Now, just like the last question, you put 45/4 there. Interesting question, though. If I asked you what's the center, that'd be easy. I already found it over there. But if I asked you it is all minuses, right? Yeah. If I asked you what the radius is in exact form, here we go, we can't panic again. Square root of a fraction, can I root it? What's the square root of 4? So I can root some of it, and that problem where I can't have a radical in the denominator. Okay, I took care of that. What's the square root of 45? What's 45? What times what? What's 45? What times what? You probably waited for the 3, 2, 1, sorry. And then what's the square root of 9? 3, 2, 1, go. 3 root 5. Of course, you couldn't graph that. So if I had to graph it, I'd have to get the approximation. So here's exact. Here's the approximate, which would allow me to graph this, which I'll just talk about but not do. What's 45 fourths? That is 4 times 9 is 36, right? So 36 fourths is 9. 45 fourths is just a little bit bigger than that. So it'd be 9 point something. All right. And then all you would do is go to the center and go 9 point something up, down, right, and left and estimate those points. That should not be something I have to do for you. You can write that down. Okay, so that's how you would graph it if I asked you to graph a radical radius. Get the radicals decimal and estimate. I'm done graphing. Okay, we're just going to go ahead and find the last few answer things here. All right, again, the trade-off is today is the long day, tomorrow is your day. I think I'm going to do a computer thing though first, and then shove a worksheet at you and do something with that. This is ridiculously easy. Just giving you a moment to write it down. What's the most important point in the circle? The 3, 2, 1, go. Center. So everything gets translated left and up, then so does the center. By the way, where's the center of this circle? 3, 2, 1, go. 0, 0. What's the matter? You got the fly! Nice! Here, I'll take it. Just go ahead. Right on your worksheet. All right, go get a major award. Yes! The fly killer. Nice. Let's give her a hand. Nice. I'm so glad that happened during the notes. That was great. What'd you get? Nice. The cell phone eraser. Okay, that was exciting. All right, center 0, 0 for this one. So all that means is our new center is going to be, what is our new center going to be? Is it going to be 1 or negative 1? 3, 2, 1, go. It's negative 1. And then up 3. 3, 2, 1. What is it? 3. Okay. So then the new equation is just x plus 1 squared. That is hilarious. When you go home, are you going to tell your parents and guardians what happened today? It's a major event. That doesn't change, though. The radius doesn't change, so it's still 81. The radius would be what? 3, 2, 1, go? Ooh, 9, because that's radius squared. All right? I'm not graphing that. We don't have the time. Okay. Now, I will say this. You should probably, before this example, put 2 formulas here. Remember what I told you about deriving pi? It came from circumference. And I know the stick in the ground or the pole, and then the string tethered out, that's a radius. But when I read my book, they actually doubled the radius. What's double the radius again? One more time. Diameter. And actually, I'm going to write this in those terms. They got this mysterious number from taking the distance around the circle divided by that diameter. And no matter how big the circle was, this ratio was always consistent to that magical number that they were obsessed with getting the exact answer. And it took centuries to get that exact answer. It wasn't probably until technology that we got that decimal that we know today, 3.14, and then it goes on forever. So really fascinating, that book, like how obsessed they were with this number. But if I multiply both sides by d, then I get this. Oh, but what's a diameter? It's 2 whats? 2 radii. So here's another incarnation of this formula. Same thing. I don't know why students make a big deal out of this. They often confuse these 2 formulas. Not these 2, circumference and area. What's area? Pi r squared. You know why they confuse them? Because these 2 formulas have a pi, an r, and a 2 in it. And often flip-flop them. There's a huge difference between 2 times a radius and a radius squared. Huge difference. So we should be aware of those. Again, ACT, SAT, these are expected to be memorized and known, you walking into those tests. So I have circumference given of this particular circle. And I'm not going to graph again. We don't have the time. So let's look at this one. This was terrible last hour. And I don't understand why this was so bad. So what's the diameter? 3, 2, 1, go. That wasn't many people either, and I'm a little concerned. 3 times pi, pi times d. D has to equal what, everybody? 3. So what does that mean? R equals? R equals, he did it, and I don't like it. Not 1.5, but 3 halves, right? Because now when I plug this into what is the equation of this circle, I can take that 3 halves and square it without a calculator. What's 3 squared, everybody? 3, 2, 1, go. Nobody, they gave up on me. So did my pen. That was funny. You didn't answer. My pen didn't want to write it. And then what's 2 squared, everybody? 3, 2, 1, go. 4. Some people, stop asking me questions, Mr. Samuelis. This is why I get the calculator out and ask individuals to answer in front of the class. Teaching in America. Boy, back in the 90s, late 90s and 2000s, it was like a course. Students used to just answer questions. We all high-fived during the notes. It was so much energy. It was so great. That's kind of a lie. I just thought I could say that, though, and just see if you guys are like, really? Wow. Uh-oh. We're taking baby steps on completing, anyone? Anyone? Square. Hey, let's do it. When I say complete this square, you say a half the middle term, and then what? Square it. I don't see your lips moving. Okay, now look at this equation. X squared plus y squared plus 2x plus 1. This is the baby steps. Do you see y squared is all by itself, right? Okay, so here's what we're going to have to accomplish. Again, I did this with parabolas. What do I have to accomplish? I have to get this to happen. Do you see any y with the y squared? Yes or no? What do you think the y coordinate of the center will be then? 3, 2, 1, 0. There's nothing else with it. Here's the baby steps. I left you something where, and even on the homework I did this, where I only have to complete the square on x. And we got to understand, okay, wait a minute. This has to turn into this, just like in parabolas. Okay, so I'm going to have to do the complete the square thing. I'm going to need a blank for this. So I put the blank here. Then I see that y squared is all by itself, and it will remain by itself. So that's why I asked that question. What do you think the center's y coordinate will be? It'll be 0. And guess what 1 needs to do? It needs to get out of here. Subtract 1 from both sides, and you get 3 on the other side. So I'm getting there. And that's what's different with the circle. That's why parabola has its own file folder. Parabola, I get all the squareds, and the other term, that's the same variable on this side, and everything else on the other side. That's how a parabola is completely different than everything else. This, we keep all the x's and y's on this side, get all the numbers on that side, because it's going to end up being the radius squared. Okay, what's half of the middle term? 3, 2, 1, go. What's 1 squared? And then why is that? Oh, by the way, whatever I do to one side, then I almost did that here, and I almost did that in first hour. I was all proud of myself that I completed the square. I forgot about that basic balancing of an equation. I added 1 to this side, which makes this heavier if you think about weights, a fulcrum. So I have to add 1 to this side to keep the balance, because that's what an equation is. It's balance. You know what a fulcrum is, right? When you have weights, when you weigh stuff in science. Have you ever weighed it on a scale? Okay, that's what an equation is. It's a scale. And then what multiplies the 1 and adds to 2? What's the answer to that? 1. This is x plus 1 times x plus 1. And then that's convenient. The center is -1, 0 with a radius of 2. And then I could graph that. 2 up, 2 down, 2 right, 2 left. 4 minutes. I got to set up this last concept. Tomorrow we're going to stretch you out a little bit further on completing the square. Then when we get to ellipses and hyperbolas, it does get more complicated. And then we're going to revert back to more complicated circle and parabola completing the square. Don't be putting those notes away. By the way, as you're writing this down, input, say it. So how come I know this is a point on the circle? What's 6 squared? 3, 2, 1, go. What's 1 squared? 3, 2, 1, go. What's 36 plus 1? 37. So that is definitely a circle, a point on the circle. And I'm going to real quick graph this. The center is 0, 0, and it does go about 6 high, right, left for the radius. I don't have time, so that's a little past 6, square root of 37. So here's 6 comma 1. It's like right here. I have no time for this, so I just got to shove this example at you here. This is what a tangent line is. It skips off that point once, and only crosses that circle once. If I bent that line in any way, shape, or form, it would cross the line twice, through that point and another point. That's why calculus people are obsessed with tangent lines. Because when equations mirror real world data, finding the tangent line at certain points on that graph is something major. Let's just put it at that. But here we go. There's people snapping their stuff away. We have 2 minutes. I don't understand it. Oh, I make these mental notes. Here's the thing that we got to understand. What did I just draw there? That second thing. Starts with an R. 3, 2, 1, go. Radii coming from the center. That's where they have to come. That's stupid. Hitting a point of tangency are perpendicular at that point of tangency to the tangent line. So here's what I want to do. From 3 days ago, I want to find the slope of that radius. So here's the slope of this radius. If this is 6 comma 1, and by the way, I knew this was 0, 0 because the equation is x squared plus y squared. The slope of the radius is y minus y over x minus x. Now let's color this in green. Let's say this is green, this tangent line. So what's the slope of the tangent line? What did you learn or remember or be reminded of Monday? What's the slope of the tangent line then? -6. It is the opposite reciprocal. That is the slope of that green line. Now, how do I find the equation of this line? It passes through this point and has this slope. Point slope form is what I'm going to insert for that. And then that's where I stopped last hour. You could distribute and then add 1 and get the final answer. So that is actually a good end. For those that put their notes away, good luck.